October 12, 2024, 2:12 in the afternoon, Yokosuka, Japan. USS Preble slides past the breakwater with 96 missile cells aboard. But the weapon-changing naval math is not in those cells. It sits above the deckhouse in a white turret, no rocket motor, no warhead, just a beam. This destroyer was built around interceptors that sprint across hundreds of kilometers. Now it carries a system that spends electricity instead of explosives. A warship designed to fire the SM-6 interceptor is suddenly protecting itself with light. Why would the United States Navy ever choose that? Because the contradiction is real. In fiscal year 2024, one published estimate put an SM-6 interceptor at roughly $9.57 million a round. In that same budget cycle, the Pentagon asked for $1.62 billion for 125 SM-6 missiles under a multi-year buy. Every launch is not just a shot. It is inventory, production time, and industrial strain. Now sit with that for a moment. The older Navy laser prototype was publicly described at less than $1 per shot, and Navy engineers later described directed energy in the realm of dollars or cents per engagement. The missile can fly about 370 kilometers at roughly 1.03 kilometers per second. The laser reaches the target at light speed, but only inside line of sight and only if air, haze, salt, and geometry permit it. Conventional wisdom says that trade is absurd. Yet conventional wisdom was built for duels. It was built for bombers, cruise missiles, and the occasional raid. It was not built for a future where a drone costing $20,000 to $50,000 can make a destroyer consider spending millions. So the deeper question is not whether the laser is stronger. It is whether the Navy finally realized it was solving the wrong problem with the right missile. If that question bothers you, good. It means the viewer is not here for slogans. It means the viewer thinks in reload limits, thermal loads, firing arcs, and combat systems. Type the word engineer in the comments. It tells the rest of us exactly who is in the room. Subscribe to Naval Tech Frontiers. We do not sell headlines, we solve equations. Critics called Helios a science fair turret. They called it a weather toy. They called it congressional bait. They looked at 60+ kilowatts of laser power and compared it to a missile carrying a blast fragmentation warhead across 370 kilometers, and they declared the contest over before the ship ever left the pier. That was lazy arithmetic. Helios means high-energy laser with integrated optical dazzler and surveillance. In plain language, it is not just a beam that burns. It is also a lower power eye that can blind sensors, confuse optics, support identification, and help crews decide whether the contact in front of them deserves a missile, a warning, or a kill. That matters because warships do not fail from lack of violence. They fail from bad allocation. The distinction is everything. Lockheed Martin delivered Helios to the Navy in August of 2022 as a 60+ kilowatt class system. The Congressional Research Service described it as a 60 kilowatt class laser with growth potential to 150 kilowatts. That growth number matters because a naval laser is not a static invention. It is an architecture. It is a path from counter-drone work today toward harder targets tomorrow. Critics missed that too. They also missed integration. Helios was not built as a separate carnival ride bolted onto a ship for photographs. It was built to plug into the Aegis combat system of a Flight II Alpha Arleigh Burke-class destroyer. That means the laser does not live alone. It lives inside the same decision ecosystem that sorts treks, assigns priorities, and decides whether a contact is a decoy, a scout, or the front edge of a real strike. Run the numbers. An SM-6 interceptor is about 6 to 55 meters long. Its body diameter is roughly 0.343 meters. Or 0.53 meters with booster hardware. It occupies physical space, industrial labor, testing cycles, shipping, storage, and one vertical launch cell that can never be used again once the missile leaves the ship. A laser shot occupies none of that. It occupies time, electrical power, cooling capacity, and line of sight. That is a different economy. Helios gets to its effect by spectrally combining multiple fiber lasers into one high-quality beam. In plain language, the system takes several smaller light sources and merges them into a cleaner, more precise stream of energy. That stream then rides a stabilized beam director, which is the mount that keeps the weapon aimed while the ship rolls, pitches, vibrates, and drives through salt air. Critics like to say a destroyer is too unstable for fine optical work. Then the Navy tested it at sea anyway. The older laser weapon system on USS Ponce had already burned small boat targets and downed a Scan-Eagle unmanned aircraft in the Persian Gulf from September through November of 2014. That mattered because it proved a naval laser could survive heat, wind, humidity, and deck force. Helios pushed the idea forward by combining hard kill and soft kill functions in one shipboard package and tying them into the fleet's actual combat logic. Not a demonstration raft, not a lab bench, a fleet weapon. By fiscal year 2024, Preble used Helios in a formal test against an aerial drone. The Pentagon's Operational Test Office counted 32 directed energy-related tests that year through the Center for Countermeasures. The Navy had already fielded 8 Odin optical dazzlers on destroyers, and Helios stood one rung above that, adding destructive power to the same family of thinking. First you blind the sensor, then you decide whether to burn the airframe. Then you save the missile for something that deserves a missile. This is where the critics fall behind. They compare Helios to the SM-6 interceptor as if both weapons exist to solve the same slice of the same engagement. They do not. The missile is for what is far, fast maneuvering, or too hard for a beam degraded by weather and curvature. The laser is for what is close, cheap, repetitive, and designed to exhaust the ship before it ever reaches the hull. By 2025, China was still unveiling laser systems in parades. America had already put one inside the nervous system of a destroyer and fired it from the fleet. That is the gap. But the asset still carries a visible weakness. A laser cannot shoot through the horizon. It is not an all-weather weapon. Atmospheric absorption, scattering, turbulence, and thermal blooming can all steal power from the beam. And saturation is merciless because a laser works one target at a time, so the problem changes. The ship now has a weapon that can reverse the cost curve at close range. Good, but the sea does not offer threats in clean sequence. Drones can come low and from multiple bearings. Fast attack craft can hide in coastal clutter. A sea-skimming missile can stay below radar longer than planners prefer. A laser solves a cost problem. It does not solve horizon geometry, raid density, or the fact that a destroyer can only point one beam in one direction at one moment. That is cold water. Line of sight is a tyrant. Weather is a tyrant. Time is a tyrant. And a ship with 96 launch cells still cannot afford to waste them on every decoy and every cheap scout wandering into range. So how do you solve a problem that firepower alone cannot fix? You stop thinking about weapons as objects. You start thinking about them as layers. The answer was never Helios alone. The answer was a system that lets each layer do the work only that layer can do. Aegis searches far. Offboard sensors and shipboard radar build the picture. The lower power optical function can dazzle, identify, and buy decision space. Helios handles the close, visible, lower-end threat set that would otherwise bleed the ship's magazine. The SM-6 interceptor stays reserved for the target class that justifies $19.5 to $7 million, a missile body over 6.5 meters long, and a launch cell that vanishes the instant the motor lights. Now the geometry appears. Imagine concentric circles around the ship. The outer circle belongs to information. The next belongs to missiles. The inner circle belongs to directed energy, guns, electronic attack, and brutal time discipline. If the captain lets cheap targets force expensive shots in the outer circles, the ship reaches the decisive moment poorer than it should be. If the captain pushes cheap targets inward under control, the ship spends electricity where electricity works and saves missiles for the threats that will not politely wait inside beam range. That is not thrift. That is doctrine. Run the numbers again. Take a raid of 12 cheap drones. If 12 SM-6 interceptors answer 12 cheap airframes, the ship may have spent well over $114 million in missile value, and it has also burned 12 cells it cannot reload at sea during the fight. 12 cells. On a destroyer with 96 total. And those 96 were never all dedicated to air defense in the first place, because a real warship also carries weapons for anti-submarine warfare, land attack, and surface combat. The beam changes that equation before the shooting even starts. A 10-second dwell at 60 kilowatts is roughly 1/6 of a kilowatt-hour of delivered beam energy. even after accounting for inefficiencies, cooling burdens, and the ugly truth that shipboard power is not household power, the engagement still lives in the world of electrical bookkeeping, not ordnance replacement. Coins and current on one side, millions and launch cells on the other. This is why the laser belongs inside a system. From the enemy's side, the picture becomes suffocating. The destroyer does not panic. It does not throw its most expensive rounds at the first cheap shape on the screen. Sensors begin to lose clarity. One drone's camera blooms white. Another loses track. Another suddenly burns at the skin because the beam sat on one panel too long. The missile cells stay closed, which means the enemy cannot tell which tracks are consuming the ship and which tracks are merely feeding it data. That uncertainty is paralysis. The enemy solved for magazine depletion. America answered with engagement discrimination. The enemy assumed a destroyer would spend a missile on every problem. America built a ladder of force where the lowest rung is light, the middle rung is layered defense, and the highest rung remains the SM-6 interceptor and its kin. A worthy opponent will keep adapting. That is what worthy opponents do. But adaptation becomes harder when the defender stops paying premium prices for discount threats. Think like a chess player. The queen is not the only piece that matters. Pawns shape space. Knights shape options. The board is won by preserving the pieces that matter for the move that has not yet appeared. Helios is not the queen. It is the weapon that keeps the queen alive. It preserves the ship's most precious currency, which is not courage and not even money. It is shot discipline. And shot discipline keeps ships alive. That is why Secretary of the Navy Carlos del Toro corrected himself in public. Helios was not a replacement for existing missile defenses. It was a supplement, an answer to a gap, a way to handle air drones and other lower-tier threats, without pretending that every inbound contact deserves the same response. The Navy did not choose the laser instead of the SM-6 interceptor in every circumstance. It chose the laser first when the system set of missile would be wasteful. That distinction is the whole story. On Preble, that story eventually narrows to a sailor young enough to be mistaken for a college sophomore. Fire Controlman Seaman Luke Harlan is 19 years old, from Salina, Kansas. His job is brutally precise. He helps maintain track quality and engagement stability at the console chain that turns radar truth, optical truth, and ship motion into one coherent firing solution. If he drifts, the beam drifts. If the beam drifts, seconds vanish, and seconds are the fight. He hears fans, pumps, and the constant machinery hum below the deck. He feels the ship through the soles of his boots, a low vibration from turbines, shafts, and the sea itself. His left hand lives on the console edge. His right hand works switches and confirmation inputs with the small economical movements of someone who knows that panic wastes time before it wastes anything else. He is 19. By the third watch rotation, his eyes burn. The display never blinks, but he does. Salt dries at the collar. Coffee turns cold. Behind every clean engagement chain sits the fact that he is carrying responsibility that would have stunned him at 17. Somewhere outside the skin of the ship, the contact is only aluminum, wiring, plastic, fuel, and intent. Inside the skin of the ship, it becomes a test of whether a 19-year-old from Kansas can keep one box steady enough for physics to matter. Then he does it. He holds the track. He trusts the system. He lets the beam dwell where the engineers said it must dwell, not where fear wants it to wander. No speech. No theater. Just correct work done on time under load. He represents a fact older than any weapon in this video. The American fleet runs on young hands performing exact tasks without room for ego. This is not a laser story. This is a sorting story. This is not a contest between Helios and the SM-6 interceptor. This is a contest between two ways of thinking about war at sea. One way sees every threat as a target to destroy. The other sees every threat as a variable to classify, route, and answer with the cheapest force that still protects the ship. The first way burns itself out. The second way scales. That is the reframe. The enemy's fatal miscalculation was precise, not foolish. It assumed the right equation. Cheap drones against expensive interceptors. Saturation against finite cells. Repetition against industrial lead times that can stretch beyond 2 years. All of that was real. But the enemy chose the wrong variable. It treated the ship's missile load as the center of gravity. In truth, the center of gravity was the Navy's ability to redesign the engagement ladder itself. America's advantage is not louder steel. It is systems design. It is dimensional thinking. It is the patience to let a 60-kilowatt beam do the work of preserving a $9.57 million missile for the target only. That missile can kill. It is the industrial calculus to understand that 125 new interceptors, even inside a $1.62 billion buy, are still a finite answer if commanders keep spending them on discount threats. And it is geometry, the old naval truth that range, angle, time, and horizon decide more battles than slogans ever will. So the 87-cent idea lands where it should. Not as a gimmick, not as a utility bill, as a category shift. The beam lives in the realm of electrical margins, cooling loops, and dwell time. The missile lives in the realm of high-end interception, distant geometry, and strategic scarcity. When the fleet places each threat in the right layer, the paradox disappears. The laser is not cheaper, because it is better at everything. The laser is cheaper because the Navy finally stopped asking one weapon to solve every problem. Stone could hold this sentence. The fleet that assigns the right layer at the right moment wins before the magazine runs dry. So go back to Yokosuka. October 12, 2024, 2:12 in the afternoon. Preble eases into port with that white turret riding above the deckhouse and 96 launch cells buried below. At first glance, it looks like a destroyer that replaced its faith in missiles with a science project. Now we know better. The Navy chose the laser over the SM-6 interceptor in the engagements where spending a missile would be strategic self-harm. It chose light for the close, cheap, visible threat so that missiles remain available for the fast, distant, hard problem that only missiles can solve. Helios did not dethrone the SM-6. It defended it. And behind that decision stands a crew, a 19-year-old from Kansas, watchstanders in dark compartments, engineers managing power and cooling, officers making classification calls that must be correct before the horizon collapses and the raid arrives together. Machines matter. But the reason those machines matter is that Americans keep learning how to fit them into a system that thinks before it fires. If the viewer stayed for that, the viewer belongs here. Subscribe to Naval Tech Frontiers. We do not sell headlines. We solve equations. Sleep well. The watch is set,